Hello, everyone, and welcome back for our next set of presentations. We're going to get right started here with J.D. Marks of Maxar Technologies, presenting on the implementation and configuration of core flight systems on the power and propulsion element provided by Maxar Technologies. J.D., it is all yours.
Thank you.
And I should have...
Yep. Oh, go ahead. I'd just really like to thank APL and specifically you too, Brandon, for putting this workshop together this year. I know how much work it is. And so I'm J.D. Marks. I'm currently the principal flight software engineer over at Maxar. My role is I'm the RE on the PPE program responsible for cFS integration. So if that's enough acronyms for you. I've worked in various roles on programs like Kepler, the Hubble resurfacing mission, even back on James T. Webb about, I don't know how many years ago, early on in the gimbals. So yay, that finally launched. Juno, OSIRIS-REx, I worked on the ARM, various no-name missions. I was a software lead down at Blue Canyon on DARPA's Blackjack. And I've been PE on a few of the NASA SBIRs involving things like onboard planning, processing, and database utilization. So that's kind of my background in aerospace. But the first half of my career involved telecommunications and networking. So I witnessed the adoption of the OSI layered model and the standardization of protocols within each of those layers. And it's always left me amazed at how flight software has been developed in the aerospace community, and obviously not with that kind of an architecture. So I guess a good example would be if you think the internet in itself, or even just Ethernet, that never would have been possible without a layered, standardized, open source architecture. So you kind of see where I'm leading with that. And that's a completely different talk. I could go on forever. But the reason I bring this up is I wanted to really thank Goddard and NASA for providing cFS. I realize it's been a long road, and I feel that the Gateway program could be the final hurdle towards actually gaining industry approval and adoption for cFS, which is also another topic. But I do want to thank Dave and Alan and Jonathan and Lori and Susie and all the other folks I'm forgetting that fought really hard to put this together years ago. So I just want to tell you all I really appreciate it. But given my background, you can understand why I wanted to join Maxar and specifically be involved with the Gateway and the PPE program. So once again, the title of this is the implementation and configuration of core flight on the power and propulsion element. In short, it's cFS on PPE. Next slide. This is kind of the disclaimer. Due to the acronym soup, ITAR, everything else like that associated with this program, I won't be covering specific details. I will be discussing how PPE is configured cFS within it to run, and the OS running will be VxWorks 7. Next slide. So what is PPE? PPE is the solar electric ion propulsion module. So it's ion propulsion, and it's going to provide propulsion, power, and a communications relay on the Gateway. And if you're not familiar with the Gateway, it's going to be the lunar orbiting outpost that's going to support long-term lunar surface missions, in addition to act as the deep space mission staging point. The way I think about it, and I tell people when I'm talking about it, I just tell them it's the lunar space station. Maxar is going to be utilizing its long and successful flight heritage on previous missions, while also adding the functionality necessary to integrate into the Gateway. To achieve this, Maxar is going to be implementing cFS. PPE will launch in a 2-flight board configuration. The flight proven heritage within the Maxar bus will reside on one of the boards, and internally we term that the ICU. I'm not going to be talking about that at all. The other flight board is going to be a 4-core processor. It's rad hardened, and we refer to that as the mission processor, or the MP. The MP is responsible for performing all the functionality associated with the interoperability to the Gateway and the Gateway modules. Next slide, please. So the mission processor, the MP, is where CFE, OSO, PSP, and all the apps will reside. It's in addition to some of the heritage apps. It's a 4-core rad-hardened processor, and we'll be running VxWorks 7 as the RTOS. Early on, it was recognized that developing proprietary architecture and custom applications to interface with the gateway was completely impractical from a budget and schedule point of view, which, soapbox time, it's another validation for the very reason cFS was developed in the first place. We're going to be utilizing 3 different kinds of cFS apps. We'll be using the open source apps that are available to everybody on GitHub. Then we're also going to be utilizing quite a few, actually, apps that were developed by the Gateway program, and they're being funded by NASA. And then finally, we'll be running Maxar specific IP apps that will provide specific functionality within the PPE. The Maxar developed apps are going to provide functionality such as synchronization with the Gateway's overall system managers, interfacing with heritage apps, and any other functionality not provided by the open source apps or the Gateway program apps. As you can see, the ability to integrate apps developed outside of Maxar eliminates the need to internally develop this functionality. Plus, the interoperability provided through their use will significantly reduce the testing necessary before we fly. If you can go to the next slide. This one's a bit of kind of eye candy, and I could spend forever discussing it, but really I want to get, and we may even come back to it at the end, but what I really want to get across on this diagram is to show 2 of the major points with our implementation. One of them is, as you can see, there's 4 cores sitting there. And I bring that up because I want to, one of the things we're going to take advantage of is actually the multi-core architecture. Then I also want to identify, and everybody is aware of it, but just make it very clear that there's things that operate in the kernel space and there's things that operate in the user space. So the majority of the VxWorks implementations of cFS that I've seen of, so, obviously people are probably out there doing it, and I don't want to say nobody is, but they're almost always done as DKMs. And what a DKM is, a downloadable kernel module that VxWorks provides. But the thing about that is they're downloadable kernel modules, so they execute in kernel space. So at this point, that means all of your cFS apps are now running in the supervisor mode. They're right in the heart of protection ring 0. And so this allows them privileges that aren't necessary and potentially catastrophic to the mission. The most obvious thing is that you don't have stringent memory protection. So whereas if you run your applications in user space, you're running outside of the kernel, and therefore the OS provides protections from corrupting the kernel in addition to memory space partitions. VxWorks utilizes real-time processes to implement this. So the term is RTPs. Then onto the multi-core, the multi-CPU core provides us the ability to specifically target the area where an individual task will execute on the specific hardware, the CPU. This allows us to do some pretty sophisticated resource loading. So as you can see by this diagram, the one thing we're not doing is modifying cFS at all. And this is, you see it a million different ways, but this is pretty much the cFS architecture right here. If you do notice, and it's kind of one of the things that is still an open trade and I need to discuss, is those pink rectangles that you see. I didn't label it such, and I apologize, but in this diagram, I wanted to show that all the apps, theoretically, we don't know how the final configuration will be, but all the apps in Core 3 and Core 4 could be one RTP. And then the apps in Core 2 could be another RTP. The problem with that is we're still not 100% sure about the software bus network. So we're currently performing a trade, and to find out exactly RTP usage on it, and also the issue of the software bus. The trade that we're performing right now is essentially, do we put CFE down into kernel space, which would be one, and therefore the software bus is accessible everywhere? Can we put the software bus inside of one RTP and have it accessible by another, which all indications are no. So therefore, do we then use a software bus network to communicate between RTPs? The long and short of what I'm saying is that's an open trade that we're working on right now. My preference would be to see if we could get CFE down as a DKM in the kernel space and then run everything as an RTP. Sorry about that. Next slide, please. So on this one, if you look at the title, a lot of people, I threw it up there and didn't even realize a lot of people might not know what that means, but I grew up here in the mountains with a lot of snow. And so what that term refers to is if you're the first one to plow through really deep snow and you make the path easier for everybody that follows you. So I mentioned all three of these previously, but PPE's cFS configuration will be unique as far as I'm known, in as much as that it's incorporating all three of these configuration items. And of course, the three configuration items are utilizing VxWorks 7 as our RTOS, running cFS as an RTP up in user space, and utilizing the core affinity capability to do resource loading. Next slide, please. So to address user space, I'm one off. You can tell I've got to keep my notes. But user space cFS execution gives us there's history, and I'm not sure, the previous OS that Maxar has used has memory protection inherent into the OS, something that VxWorks never really had. So a way of competition was they came up with RTPs to give you the memory protection. So it's pretty critical within Maxar that we have that memory protection, and therefore it's kind of an internal requirement that we will be running all the CF apps as RTPs. We have further work going on right now that I just mentioned, because we need to know exactly what the optimum configuration is. Do we run CFE down in kernel space and then run all our apps in specific RTPs, one for each core, or all of that is still to be determined. But we do know that we need that memory protection provided by running in user space. And therefore, we will be running all of our cFS apps up as RTPs in user space. And I do kind of a note here, that last bullet. When we've run into issues with VxWorks and cFS and everything, I want to make sure I give a shout out that NASA's support's been invaluable in this, especially Jonathan. So I really appreciate that. Next slide. I'm not even sure why this slide is here. It shouldn't be. The industry in general, any of the companies that I've been involved with, and most of them are fairly large, are still running VxWorks 6.x. 7.0 came out in 2014. The big problem with that is right now, Wind River has just announced that they're planning on end-of-lifing the 6.x products. So theoretically, if we stayed with VxWorks 6, we could have an end-of-life product before we ever launched. So just given that alone, it pretty much almost mandates that we have to go to 7. The jump to VxWorks 7 by people who have come up that migration chain and are very, very ingrained into VxWorks 6, it's hard. It's a pretty significant jump. So that's where Maxar is kind of in a really good position right now, since all of their heritage functionality was not developed utilizing VxWorks. This means that it gives us the opportunity, a greenfield opportunity, to just implement with VxWorks 7 and not have to worry about rolling back on anything. I will say that the work necessary to build cFS with VxWorks 7 has not been trivial. There's a lot of things, and back to my previous comment of the help that we've gotten from Goddard, it's been invaluable on some of the stuff. But that being said, there was nothing special or nothing fancy that we had to do outside of exactly how cFS outlines implementing a new OS, to get cFS up and running. Once we had all our problems solved, everything was right along with the way you're supposed to do it. And it ultimately pretty much ended up just being a change in that tool chain file, the CMake file, and the PSP directory. We had to do a VxWorks directory and the PSP. Those were the two big changes. We did run into problems with the kernel. So inside VxWorks, inside the kernel configurator on 7, there were some issues that we ran into, and I was tracing them down for quite a while, ended up actually having to go back to Wind River, and they filed a couple of erratas to fix those problems. Once they got that taken care of, we were able to get cFS running on our target board, our development board, with VxWorks 7. Next slide. Sorry, and I'm just zipping through this, so I may end early, so hopefully there's a lot of questions. The apps executing on specific cores. This has got, typically everybody thinks, okay, symmetrical multiprocessing, parallel processing, whatever else, and we can really resource load things and let the scheduler load them. But one aspect of targeting specific cores or doing core affinity is the fact that it gives us 2 levels of resource loading. So, all of us that have dealt with the RTOSs, even on a single CPU, we're all very, very familiar. Okay, I'll set my priorities and the scheduler will preempt when it needs to, and what we're traditionally used to. Now, when you can do core affinity, the nice thing about that is you can step up one level in your architecture and define specific subsystems that have priorities. And I mean, it could be the lowest priority if you want, but typically you're going to take a subsystem that's super critical. It could be data acquisition, it could be something else. And you're able to put all of those apps or /tasks associated with that subsystem on that specific core. Then once it's all sitting on that core, you can prioritize your tasks within that. But that second level of protection that I'm talking about by doing that is if I have a task or an app that's, let's say, I've got my high priority core that I'm running things. So I have a task, we'll just call it 5, 4, 3, 2, 1. So over on that core, my task that's a 3, or my app that's a 3, is all of a sudden going to be running based on the scheduler for that core. But over on another core, I actually have a priority level 4 task that's coming up to run. It's not going to preempt. In other words, my level 3 task will not be preempted inside that core. So I'm probably not explaining it real well, but you can see where it gives us just an added level of resource allocations. So this is really, really strong piece of equipment that we've got in our toolbox now that allows us to profile the system as we're testing it and getting everything down to optimal performance. And then the MP is the only one that has the multi-core. So that's a really fast overview. I wish I could go down into a bunch of technical details. You'd never get me stopped. But this right here is how Maxar is planning on implementing cFS. So next slide, please. So just to summarize the things that I've said, Maxar's implementation of cFS on PPE, it's not just Maxar developed cFS apps that we're going to be executing on there. We're going to be executing apps that were developed by open source, the NASA Gateway program, and theoretically, if any of the other partners wanted to provide apps for the Gateway program, we should be able to integrate them. The development and test costs savings, which is part of that other talk I would have had are incalculable. It just, if we would have had to go out and bid this project, because it's a fixed cost bid, if we would have had to go out and bid this and roll in those costs of all the development for that functionality, you can imagine exactly how much more it would be. Then the NASA individuals, the nice thing about too is Core Flight once again verifies itself. The folks over in the NASA Gateway program who are developing apps that we'll be utilizing on PPE, I strongly believe that they have no idea what OS we're running or what our hardware is going to be or anything about our configuration. Yet they're developing apps that we're going to be able to pull over into our system and bring up and integrate very, very quickly. And they will already have tested interoperability with the other apps on the software bus over sitting in the other modules in the gateway. That was impossible before. You know, when everybody has their own proprietary architecture, you know, I won't name names, but I was working in one organization where they had within their space area 4 different flight architectures. You couldn't even take code from one program and give it to another program within the same company. This is pretty groundbreaking. And then another thing that's pretty big on this is that PPE will be demonstrating the ability on the same board actually to run a cFS architecture and still interface and run heritage applications. I'm not sure if I've heard of anybody else doing that, but it's pretty unique. So that in summary is at a high level how Maxar plans on configuring cFS to run on our mission processor. But as one last cut, because you haven't heard me say it enough already, I just wanted to get back on the soapbox a little bit. And I wanted to point out that cFS was originally developed just to provide an open source framework that would allow applications to go from one program to another and give us a standardized framework. I don't know that anybody originally foresaw the ability, and the software bus network obviously was the key piece, but ever foresaw the ability to do interoperability between different spacecraft. And so one of the things that you just kind of think about is imagine a constellation of however many buses sitting up there, and they're all manufactured by different people, different primes, put them up there, but they all communicate just fine. And they all share applications within that, you know, within the program itself. Or the big term right now, swarms. You know, imagine a swarm that it's not dedicated to one provider. And then of course, imagine Gateway, you know, where we've got right now, PPE and Halo are going to launch together, but you know, there's going to be IHAB and Orion, and we're all going to be able to interoperate within each other. So that's it. And I really appreciate, you know, giving me time to stand up here and talk to you. And a little bit of a soapbox on Core Flight, but everybody who knows me knows I'm going to do that.
Thank you so much, JD. We do have some time for questions, and I just saw a bunch of them come in. Okay. So let's go ahead and start with the first question from Leonidas. Some of the challenges regarding memory protection on VxWorks wouldn't be eliminated if the A-Rank 653 version of VxWorks was used instead. Do you think the A-Rank 653 would have prevented you from using any cFS functionality that you required?
And right now, first of all, I would say I truly do. I like the A-Rank architecture, and I truly think there's a lot of advantages to it. It was never considered as far as that, but I don't know that it's cFS. We're not planning on doing a lot of cFS modification to provide the memory protection. We're utilizing the VxWorks ability to put everything in an RTP. So just the fact that we're building those apps in an RTP should give us that protection, you know, that this app is going to stay in its playground. And if it tries to go outside its playground, it's not going to be allowed. So I think that protection is more of VxWorks provided and not cFS. Okay.
Time for one more question, I think. Did you have a need for legacy CSCIs to interface with the cFS system? And if so, how is that implemented?
Yeah, we do. And right now, and it's interesting because on the panel, I heard Jake make a comment about how in the future, because the software bus and responsiveness, well, that's not our requirement, but in the future, we need something that will be, sorry, my meetings keep popping up. The way we're planning on doing that is to have a cFS app that is essentially an interface to the heritage applications. And does it mean that, you know, most of the typical apps sit there and wait on receipt from a message from the software bus inside their main task loop? I'm not sure, you know, moving forward, that may not be what that specific app does, but that's the lines we're going down right now as far as heritage app interfacing, is it'll be a cFS app that either is able to receive outside information through one mechanism or another, and then is able to generate the messages, the packets, or whatever you want to an interface to the outside heritage apps. So that's our current plans.
Got it. Okay, we have a few more questions, but unfortunately we're out of time, so we'll move some of those over to Slack. Thank you so much, JD.
Thanks for having me. I appreciate it.
Absolutely.